Okay, so let us finally switch to the payment calculator code. So I'm assuming you opened the payment calculator project, right-clicked on the payment calculator form, and then scroll down to the bottom where the definition of the class loan begins. Okay, we're going to start by specifying the private rather than public m underscore amount as double member variable. A private data member is going to have its value hidden from the outside world. We will need to define the public property block for writing or setting and reading or getting the values into and from the m underscore amount member variable. Okay, and we're going to do that in a minute right below here. By contrast, when we define public, not private, but public property rate as double, okay, when we do that, we automatically expose it to the outside world for reading and writing without any intermediary public property block that we'll talk about in a minute. As we mentioned before, Visual Studio automatically creates those public property blocks with set and get statements internally. We don't see them in the code, and also assigns an underscore rate member variable, which is then used subsequently in class methods and events such as this calculate monthly payment, as you'll see shortly as well. Okay, so there's nothing special about the m amount member variable at all. It was simply, I just picked it at random so I can define the public property blocks associated with this property. Okay, so right below here I'm going to have a couple of blank lines, and I'm going to have public property amount, open close parenthesis, as double. Okay, and then I'm going to go a couple of lines down and end property. Okay, so in the middle of this public property block, okay, what we'll do is we'll specify the get, okay, and then set blocks themselves. Sometimes I refer to them as get and set statements. So this is the reading part, and this is the writing part. We can separate them a little bit more, but it's not really necessary. So the get property block piece, right? It's in our case going to simply return the amount that was already presumably written, and in that sense expose it to the public, okay, or the outside world, as it were. So here there could be some transformations and additional code that maybe even verifies the user's security level or access level, and allows or disallows him or her to access this particular property. So a number of things could be done here, as well as in the set piece of this public property block, where typically a validation of the value the user now passes to this particular property is then established. In this case would be whether it's a positive dollar amount within probably or presumably a certain range. Again, we're going to, as I mentioned earlier, not be doing too much of validation. We're going to assume that the value is legit, and we'll have, as you'll see later on in the user interface, we'll have masked text box that almost assures us that we get our legitimate number here, right? Okay, so instead of doing validation, we'll simply set the private member variable m amount to the value supplied by the user. Okay, so next what we're going to do, we're going to scroll down to our first and for now the only method or procedure, or in this case function, that calculates monthly payment as double and returns it to the main program, right? So it's a simple function that will take a local mth pmt as double variable, and then we'll assign it to the result of a financial credit.pmt function using the member variable rate, which you remember is accessed by typing underscore and then using the name of the property, as you can see here. And then because it's an annual rate, we have to divide by 12. Similarly for the term, underscore term times 12, and then negative m underscore amounts to get a positive monthly payment. And then we only have to just return that MTH payment to the main function. So this is our simple calculate monthly payment method. So we have an example of a method or procedure, okay, as well as 4 properties for this particular class, okay, and that's sort of enough for us to go scroll back to the top of the main program, the public class FRM payment calculator, okay, and declare credit as an object of loan type. We're going to declare it first without instantiating, and we're going to do it at the top of the program so that it is available in both click event procedure as well as this value changed event associated with this datetime picker we'll discuss towards the end of this video. Okay, so this is just declared object of loan class type. It is not instantiated yet. Okay, we will discuss the instantiation next in the click event first. Okay, so in general, we will instantiate pretty much all of our objects using default constructors or constructor by typing simply credit equals new loan, open close parentheses. Okay, and if you put your mouse on top of that line of code, you'll see that actually is a call to a default constructor called loan.new open close parentheses. Okay, the default constructor is automatically generated when you define a class. It is not visible in a class code. Okay, and if we want to have a different constructor, then we have to redesign, essentially. If you scroll down to the class code, you'll see redesign the new method, new procedure, which is the constructor, by passing to it, in this particular case, 4 input parameters: R for rate, P for term, A for amount, and T for type, and use those parameters then to initialize these 4 properties as shown right here. Okay, then back in the main function, specifically the click event, we would then instantiate the credit object using this particular constructor with these 4 particular values being passed to it. Okay, instead of a default constructor that we are going to tend to use that does not set the properties, so the numbers are zeros and the strings are blank, and that's fine, because the next thing we're going to do, we're going to read all the input values into those properties. So we are going to essentially define those pretty much immediately after instantiating the object. There are 4 properties or 4 pieces of data we need to provide for this credit object to be sort of a legitimate loan, and you'll see it's going to be of mortgage type. The first one, again, in no specific order, is credit dot amount. So just like with the data structure, in its member variables, the properties of objects are accessed with a dot notation. Okay, so that's going to be grabbed out of the CDBL, that MTB amount text box. Okay, so again, this is almost validated. The users can still enter presumably a negative number, although nobody would do that. So the MTB amount makes sure that the user enters only digits in that particular text box. But in general, as I mentioned earlier, we would use this particular set block to validate the value being passed into that private member variable. Okay, similarly, we'll grab the term, credit.term, from cbo.term term dot text. Okay, where the drop down, as you'll see in a minute, the drop down essentially restricts the terms to certain choices. Okay, and there's no way to make the user choose 20, 30 years for mortgages instead of 3 or 4 years available for car loans, and vice versa. But that's a logical error rather than a syntax or a runtime error. And then we convert that into an integer to match the data types. We are getting the rate the same way and passing it into this credit object rate property from C double from the CBO rate. No, it's LST rate. Okay, dot text, and because it's in percent, we need to divide by 100. So that's validated again simply by being by the virtue of the fact that it is in the list box. And finally, the credit dot type is grabbed out of the CBO type combo box that is restricted to mortgages, auto loans, and other. Okay, so now that we have all 4 pieces of data assigned to this object, we can then use it and its credit method to get the obtain or calculate the monthly payment. And we're going to put it simply directly into the payment text box by using the credit object. It's calc method, calc monthly payment method, and we're going to convert it to string as currency. Okay, make sure that the project payment calculator, FRM payment calculator, is the default or startup form, and then run it. Okay, you'll see it's 200,000 here. Okay, I don't even know if you can. The user cannot even enter a negative, so this is going to be valid. That is a reasonable mortgage amount, depending. It's a median household value in the U.S. And then the term should be picked as 15, 20, 25, 30 is a default, rather than 3, 4, 5, 6 years for the car loan. Again, the mortgages should be on the lower rather than the higher side as well. And then this is the type, mortgage, auto loan, or other, and then monthly payment shows up here. And then you can do the what if analysis if you get a little higher loan, or higher monthly payment, higher value, less years, it should be much higher number, and so forth. And next we're going to get into the dates time picker and early payoff in a moment.